When replacing capacitors for site lighting, several factors must be considered to ensure proper operation and longevity. Firstly, regarding brand substitution, as long as the replacement capacitors have the same specifications, which include capacitance, voltage rating, frequency rating, and temperature rating, different brands can be substituted. It's important to note that capacitance is often expressed in microfarads, represented as either MF or MFD, and these terms are interchangeable. Secondly, the do not substitute warning generally indicates that the capacitor has specific characteristics or features that are critical for the proper operation of the device. These features might include a bleed resistor or a high temperature rating. Substituting with a different type of capacitor without the same features could lead to malfunctions or safety hazards. Thirdly, running site lighting continuously 24 hours a day can shorten the lifespan of capacitors. Capacitors tend to age faster when exposed to constant electrical stress. It's recommended to use photocell controls or timers to turn off the lights when they're not needed, reducing the stress on the capacitors and prolonging their operational life. A high failure rate with capacitors can be attributed to various factors. These include overvoltage, overheating, or even poor manufacturing quality. To improve the reliability of your lighting system, consider the following steps. 1. Use high-quality capacitors. Opt for capacitors from reputable manufacturers known for their reliability. These capacitors are typically designed to withstand higher stress levels and maintain their performance over extended periods. 2. Ensure proper voltage and frequency ratings. Capacitors should be appropriately rated for the voltage and frequency of the lighting system. Using capacitors with incorrect ratings can lead to premature failure and potential safety hazards. 3. Provide adequate ventilation. Overheating can significantly damage capacitors. Ensure that there is proper airflow around the lighting fixtures to dissipate heat and maintain a safe operating temperature for the capacitors. 4. Use surge protectors. Surge protectors can protect capacitors from sudden voltage spikes, which can cause damage and shorten their lifespan. By implementing surge protection, you can minimize the risk of capacitor failure due to overvoltage events. 5. Monitor and replace capacitors regularly. Establish a maintenance schedule to inspect and replace capacitors before they fail, especially if they are subjected to continuous operation. Regularly scheduled maintenance can prevent unexpected outages and ensure the continued reliability of the lighting system. It is important to select replacement capacitors with appropriate specifications to match the requirements of the lighting system. The capacitance measured in microfarads should match the original capacitor's value. The voltage rating must be equal to or greater than the voltage present in the lighting circuit. The frequency rating should be compatible with the power grid frequency, typically 50 Hz or 60 Hz. The temperature rating indicates the maximum operating temperature the capacitor can withstand. In addition, the presence of a bleed resistor is a critical feature to consider. Bleed resistors are designed to discharge the capacitor after the power is turned off, reducing the risk of electric shock during maintenance. Selecting a replacement capacitor without a bleed resistor could create a safety hazard. Before replacing any capacitors, it's crucial to disconnect the power supply to the lighting system. This will prevent any electrical accidents or injuries during the replacement process. Use appropriate tools, such as insulated screwdrivers, to handle the electrical components safely. When installing the new capacitor, make sure to connect it with the correct polarity, if applicable. Some capacitors are polarized, meaning they have a positive and a negative terminal. Connecting them backward can cause damage to the capacitor and the lighting system. After installing the new capacitor, thoroughly inspect the connections to ensure they are secure and properly insulated. Loose or poorly insulated connections can lead to electrical arcing and potential fire hazards. Once the replacement is complete, test the lighting system to verify that the new capacitor is functioning correctly and the lights are operating as expected. If any issues arise, such as flickering lights or unusual noises, immediately disconnect the power and investigate the problem further. It's also important to be aware of environmental conditions that can affect capacitor performance. High humidity, exposure to corrosive substances, and extreme temperatures can all accelerate the degradation of capacitors. Taking steps to protect the lighting system from these environmental factors can help extend the lifespan of the capacitors and improve overall reliability. In summary, when replacing capacitors for site lighting, carefully consider the specifications, features, and environmental conditions to ensure proper operation, safety, and longevity. Remember to use high-quality components, provide adequate ventilation, implement surge protection, and establish a regular maintenance schedule to maximize the reliability of your lighting system. By following these guidelines, you can minimize the risk of capacitor failures and maintain a safe and efficient lighting environment. It's essential to adhere to safety precautions when working with electrical components. Always disconnect the power supply before starting any repairs or replacement. Wear appropriate personal protective equipment such as safety glasses and insulated gloves to prevent injuries. If you're not comfortable working with electrical systems, it's best to consult a qualified electrician. In addition to the above, understanding the specific requirements of your lighting system is crucial for selecting the right replacement capacitors. Different types of lighting systems may have unique capacitor requirements such as specific voltage levels, frequency ranges, or temperature tolerances. Refer to the manufacturer's specifications or consult with a lighting expert to determine the appropriate capacitor type for your system. When selecting a replacement capacitor, also consider its expected lifespan and warranty. High-quality capacitors typically come with longer warranties, providing assurance of their reliability and performance. Choosing a capacitor with a longer lifespan can reduce the frequency of replacements and minimize maintenance costs over time. Furthermore, it's important to properly dispose of old capacitors in accordance with local regulations. Capacitors may contain hazardous materials such as electrolytic fluids that can be harmful to the environment if not disposed of correctly. Contact your local waste management agency for information on proper disposal methods. When troubleshooting capacitor failures, it's helpful to have a multimeter to measure voltage, capacitance, and resistance. These measurements can help identify the cause of the failure and determine whether the capacitor needs to be replaced. Also, consider the impact of capacitor placement on its performance. Avoid placing capacitors near heat sources or in areas with poor ventilation. Proper placement can help maintain a safe operating temperature and extend the lifespan of the capacitor. It's also important to periodically inspect the lighting system for any signs of damage or wear. Look for cracks, leaks, or corrosion on the capacitors or other components. Addressing these issues promptly can prevent further damage and potential safety hazards. In conclusion, replacing capacitors for site lighting requires careful attention to detail and a thorough understanding of the lighting system's requirements. By selecting the right components, following safety precautions, and implementing a regular maintenance schedule, you can ensure the reliability, efficiency, and safety of your lighting system for years to come. Lastly, it is important to remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you're unsure about any aspect of the capacitor replacement process, consult with a qualified electrician.